Number 1, and then we'll go look at number 3 because number 2 is like number 1. So I'm going to try to do one of different ones. Yes, ma'am. Yes, they are. All right. So let's look at number 1 and get that going. Okay. So you got Jason jumped off a cliff into the ocean in Acapulco, or I don't know how to say that, but anyway, while vacationing with some friends. His height is as a function of time could be modeled by this equation. Okay, anything that's launched or jumps follows a parabolic path, quadratic. So the equation there that they've given us, h of t, so his height as a function of time. Well, he may have been. You know how you guys talk about, I jumped off that cliff, and really your friend pushed you off of it on the buffalo. Yeah, you know how that stuff happens. All right, so there's our function, and some of the things that you can kind of depict from this is his initial height is this number on the end. That's how high the cliff was, 480 feet. It was a long way up. And then his initial velocity is the number in front of t. In the middle, it's b. The negative 16 t squared is going to be there all the time. Every problem you do on this worksheet has that. Okay. All right. So I would not do it, but I'm not sure how tall it is. Okay. So how long did it take? A part says, how long did it take Jason to reach his maximum height? If it's following a quadratic path, where's the maximum height at? At the vertex in the middle there. That spot right there. That's what A is concerned. It wants to know at what time did he reach that maximum height. So it wants to know the t value for that. In this equation, that's like x, right? So it's the axis of symmetry line. Where's that at? So we just use that formula. Instead of x, we're saying it's t equals negative b over 2a. Well, that'd be negative 16 over 2 times negative 16. It would be negative 16 over negative 32, which is half a second. In half a second, he reached the maximum height of his path, which seems about right because when you jump up, it doesn't take you long to get as high as you're going to get. And then you start going down. Well, he just happened to jump off the edge of a cliff and that kind of thing. So in a half a second, he's reached the maximum height. All right. Now, the next thing it wants to know is what was the highest point that he reached? So highest point on that path is the vertex. How do we find the vertex if we have the axis of symmetry? Plug it in and work it out. Yeah. H of 0.5. Negative 16. So you can use a calculator to work this out. I'm fine with that. That's what I would expect. 0.5 knots. And plus 480. If you punch all that stuff in there and get that number, it was 484 feet, which is pretty impressive that he had a 4-foot vertical. Now, I'm assuming that they were measuring from one spot, maybe the height of his foot. And when he took that dive, his foot kind of, its highest point was a little higher than what he really jumped. I don't think a 4-foot vertical, that's 48 inches. That's LeBron James kind of territory. As far as jumping ability, it's just unreal. Vince Carter back in the day, y'all don't know, y'all didn't see Vince Carter when he was in college. He was amazing. He could jump out of the gym. All right, and then it says Jason hit the water in how many seconds? Okay, so in a half a second, he's reached the vertex. When does he hit the water? What's the height when you hit the water? 0. So we set the equation equal to 0. Plus 480 equals 0. And we solve that. What are the ways we have to solve? We could, okay, well, why would we do that?
No, we don't. We
You could simplify it. I think that's a great idea no matter which method you're using. Because what do we know about the greatest common factor here? 16 goes into itself, and it actually goes into 48 or 480 in this case. So I would divide by negative 16 just to get rid of that negative, and technically I'm dividing 0 by it as well. So look for those things. Not always going to work out for you, but it does in this case. That's not plus 30, it's minus 30. And then we've got a quadratic, and we've got what methods do we have to solve quadratics? The first method we talked about in here was factoring. That's one method. What's another method? Completing the square. We usually don't want to use that. If it's in standard form already, we usually would want to use what? Quadratic formula, which is fine. This one will factor or do quadratic formula. Either way, it's going to get you the same answer. I know it'll factor because I happen to know what multiplies to be negative 30 and adds to be negative 1. X minus 6 and x plus 5. Not x, but t in this case. I have trouble swapping letters. And then you set each of those factors equal to 0. You get t equals 6 or t equals negative 5. Which one of those is not possible? Why is negative 5 not possible? Well, it's not. That t is time. So if negative time would be Back to the Future kind of stuff where you're going back in time, and we ain't figured that out yet. Yeah, before he jumped. Okay. I'm thinking at about second number 1.5, he's thinking, oh no, this is a bad idea. That's probably what he's thinking. Okay, so really, I mean, this is a word problem, but is it that difficult? No, it's the same stuff we've been doing. It's just in the context of we've got an equation dealing with the word problem. So let's flip over to number 3. I hope so too.
And this guy jumped off of one of them water things, and he hit the ground.
Yeah,
I
sure.
don't know why it was funny.
That good?
But he failed.
Not good. All right, so we're looking at number 3 on your handout pack. It says the rocket is launched from atop a 101-foot cliff. And yeah, it's a rocket at least this time. It's not a person launched off the cliff. With an initial velocity of 116 feet per second. And then A part says substitute those values into the vertical motion formula. And that's what we have here is this vertical motion formula that is fairly standard. Now, I'll go ahead and preface this by we're not accounting for wind issues when we use this formula. It's a much more complicated formula if you include the wind variable, and we're not including that. You get into calculus and differential equations when you do that. It's quite complicated. Yeah, you do, and you know when you shoot, especially right now archery season is coming up. Those really, it's easier to see those follow a parabolic path than a bullet does. But a bullet also follows a parabolic path. My pastor at church, he does long range shooting, and after it reaches so many yards, the bullet drops so much, a certain amount, and it's that parabolic path. It's real flat, but it's a parabolic path. Here, Corey Leonard is his name. His wife is the guidance counselor over at McNary. All right, so let's look at filling in that part for A. It says fill in the values. The initial velocity is v. Okay, so h of t is negative 16t squared, and then the initial velocity was 116, so plus 116t. And then h sub 0 is the starting height. It was like where did it launch from? It launched from 101 feet up. Okay. Sometimes they use h sub 0. You encounter a few problems where they use s for starting height. I don't know why it bounces back and forth, depending on which textbook you go with, which one they're talking about. But initial height, starting height, same thing. Okay, so this number out on the end is always where you're starting from. How high are you up when you jump? If you're standing on the ground, what would your starting height be? 0. If you're starting at the same height that you're going to end at. That's what's going on. B part says use the quadratic formula, so they tell us what to do to find out how long the rocket will take to hit the ground after it's launched. Round to the nearest tenth of a second. So we're running 1 decimal place on this. Okay, so B part is just taking that and doing quadratic formula. So T equals negative B, so that'd be negative 116 plus or minus, and this is 116 squared, 4 times A times C. So it looks like it's going to be a pretty big number inside of the square root there. But again, we're doing, decimal answers here. So we're talking about time. I don't know. I don't have a stopwatch that does fractions. I wish I did. That'd be cool, but it's not. And then over 2 times A, so negative 16. So let's work out that stuff inside the square root there and see what that number is. All right. That is a big number. We were expecting a big number. I don't know if I expected one that big. Yeah, that's a big number itself. Yeah. 116. All right. Make sure we all agree with Jordan. I think that's right. 19, 9, 20. Yeah. 19, 9, 20. So we got negative 116 plus or minus the square root of 19, 9, 20 over negative 32. All right. So I'm not even, since it told me to get my answer with 1 decimal place, I'm not even going to even try to simplify that radical like factor tree. No point in that. So I'm just going to go ahead and split it into my 2 problems to work out. So the negative 116 plus the square root of that number, not 920, negative 32. And then T equals negative 116 minus 19920. We're finding the time, so technically it's T. If I wouldn't count her off, you put X. There's going to be times where you want to find a height and where you want to find the T. So knowing which one you're looking for is important. I'm not going to be too picky about that as far as that goes. So let's work out those numbers. So we got negative 116 plus the square root of 19,920. And I get a positive number divided by negative 32. Round that to 1 decimal place, it'd be negative 0.8. Approximately. And the rounding of the other one, so we're taking the same work here and just putting a minus sign in there. This one should come up with a positive solution because we're dividing by a negative there in the bottom. So divided by negative 32. Positive 8.0. Rounding to 1 decimal place. And that would be seconds. Our dimension was feet per second for velocity. So 8 seconds is the one. We're going to throw that one out because it's a negative time, and negative time doesn't help us. Okay. So that finds us where, how much time it took him, this rocket, to hit the ground. And that's what you're going to be doing on most all of these problems. If you look at down 3, 4, 5, and 6, they're very similar to those. 7 is very similar to that. 8, think about what you're finding there. Number 10, I need to make mention of that. It says Rocket Club is holding a competition. There's a cloud cover at 1,000 feet. If a rocket is launched with the velocity that they give there, and they give you the equation, determine how long the rocket is out of sight. So what you're thinking is, when will it reach 1,000 feet? The first time and the second time, because it's going to reach 1,000 feet and disappear because it gets above the cloud, and then it's going to follow that same parabolic path, and it'll reach 1,000 feet again on the way down. How much time is between those, please? So 10's a little difficult, but I think you can figure it out maybe, because 1,000 feet is a height. So it goes in an H position, H of T actually. Okay, and then 11 and 12. 12 doesn't have the vertical motion equation written for you there, but it's the same one that you would use on number 11 for that. Okay, all right. That's what we're working on today, getting those things going. So I got Kegel and Zach going to take the quiz. Other than that, yeah, that way you don't have to wait till next week.